Alright, so now that we know a little bit more about fractions, we're going to start giving our answers in fraction form. And we'll start comparing fractions and trying to figure out which one is the biggest fraction and which one is the smallest fraction and which one goes in the middle. When we see fractions, some fractions are super obvious. We can pretty easily figure out what they are. Like, for example, if we had 1/2 versus 1/10, we can pretty easily compare those because they are both unit fractions. Quick check. Unit fractions mean fractions with a numerator of 1. We talked in class about unit and uno. You have one piece in your numerator and however many pieces in your denominator. So unit fractions are pretty easy to compare because I can think about, oh, what's 1/2 going to look like? It's going to be half of my whole? Okay. What's 1/10 going to look like? It's going to be not half, but 1/10 of my whole. Which one's bigger? Oh, 1/2 is a lot bigger than 1/10. Unit fractions are pretty easy to compare. They're already in their simplest form. However, most fractions will not be. So, one of the main reasons that we simplify is to make life easier for us. Simplify means make it simpler. You might as well make it easier and make your fractions easier for you to understand and easier for you to draw a picture of. Because if, for example, I took 375 500ths, and I was like, yeah, everybody, I have 375 500ths of a dollar, it's going to take me more than a minute to figure out, how much money does Ms. Douglas have? But if I simplify my fraction, and that means change it so it's still equivalent, but in much simpler form, a much easier to understand form, then it would be a lot easier for me to say, oh, hey everybody, I have 3/4 of a dollar. Suddenly that makes way more sense. So, there are a couple different strategies for simplifying. Number 1, visual representations. Visual, remember, means seeing it with our eyes, which visual representations are most likely going to mean with pictures. One of my favorite ways to prove something, and one way to ensure that you are not only telling me the correct answer, but justifying it and really proving it to me, is with a drawing. If I tell you, hey, I know that 4/8 is the same thing as 1/2, and you're like, what? How do you know? Prove it to me. I can prove it to you with a picture. I would draw 1/2. There's half. And then I would draw 8ths. Those are 4ths. Cut them each in half. Now they are 8ths. 1/8, 2/8, 3/8, 4/8. 1/2 is the same thing as 4/8. And there is my proof. If I gave you 4/8 and I was like, well, what is that in simpler form? You could draw me a picture and be like, oh, it's 1/2, Miss Douglas, because look right here. Here's my proof. You can also show it to me with math using a scale factor and saying 4/8 divided by the same number in my numerator and denominator simplifies to 1/2. Now wait, what did I just do there with the scale factor and the dividing by and all that good stuff? Hold on. Let's think about that. And we're not actually talking about visual representation. Now we want to talk about something called a scale factor. So, back to my 4/8 example. We know now, because I just proved it in pictures, that 4/8 equals 1/2. But here's another way that I can prove it. If I am showing my division I can divide by the same number in my numerator and my denominator. Why does that work? Well, that works thanks to something that has a really, really long name. It is called the multiplicative identity property. It's a total mouthful, but basically it means that any number, which we can represent since we don't know what number we're talking about with a variable, any number times 1 is going to equal itself. With the exception, well, any non-zero number is the actual definition. Technically 0 times 1 does equal 0. However, it's any non-zero number. For example, I could say 5 times 1 equals 5. 700 times 1 equals 700. 4 eighths times 1 equals 4 eighths. Now, the same holds true for division. If I had A divided by 1, it would still equal A. If I had 5 divided by 1, it would still equal 5. If I have 4 eighths divided by 1, it still equals 4 eighths. That's kind of what we're doing up here in the purple, and let me prove it to you. What would you say I have shaded in here? If you said 1 whole, congrats, you're right. But I can represent 1 whole in lots of different ways. That is an equivalent amount to 1 whole, but I might call that 2 halves. This is an equivalent amount to 1 whole, but another way I could say that is 3/3. So this is what I like to call a fancy 1. It really means 1 whole, but it can be represented as any number divided by itself. So going back to my 4 eighths example, 4 eighths divided by a fancy 1 won't change the amount I'm talking about. It'll only change the way it looks into 1/2. And that is simplifying part 1.